kept the cockroach from bleeding out and the wire from popping out. And then I anesthetized the cockroaches a little bit more, and then I worked on the antennae. So for the antennae, let me explain the antenna specifically. So the cockroach's antenna is kind of like a cylinder. When you go and you cut it, the inside of it is hollow, and it's filled with nerves and saline. So it's quite easy to funnel an electrode in there as long as you're paying close attention to it. So I funneled it in a couple millimeters and then applied the cyanoacrylate and funneled it in the rest of the way. And I did that for both of them. And then I organized the electrodes and the grounding wire on the top of the device and just hot glued it down. So there weren't any problems with that, just to keep everything from crossing. And the purpose of the surgery is only to create the bioelectronic interface. It's not the device itself. It's honestly, for me, these cockroaches are more than just test subjects. They were pets. So I wanted to make sure that if I did my project on them, it wouldn't be something that permanently damaged them and kept them from returning to their normal cycle of happy cockroaches. So this served as just a tiny little connector on the back, and that would allow me to plug my device into. And so this is the device. This is the main body of my project. So as you can see right here, on either side are Hall effect sensors, which are again magnetic field sensors. And they were fairly cheap. They were only a couple cents online. I got like 12 of them for under $10. And then you have the circuitry in the center, watch batteries, very basic structure. Most of the stuff I got from Radio Shack or like this 1960s self-science kit that my professor had in the back of his room. But and then you can see on the top, those are the 3 prongs that go and connect to each of the electrodes and the thoracic piercing specifically. And I have a diagram of this coming up. Here we are. So basically, when one of the sensors detects a magnetic field, it sends a signal to the cockroach's antenna on the respective side. And I also have a video explaining that. Just here, give me 1 second. Here we are. Okay. So you'll see the magnet approach one of the sides, and the device will activate. You'll see a little LED go off, and the cockroaches turn, and the cockroach will turn.
That's nuts. What? Cockroach is pissed.
And again, this device, you could just unplug it and put the cockroach back in the cage.
So how do you like control for a cockroach meandering down a path? Like,
Pardon?
I don't know. How do you like? I'm trying to think. Like, you have a robot and you have a stimulus and all that. How do you determine what is the cockroach doing it because you throw a magnet at it versus like a control? Does that make sense? Like, it seems like it'd be hard to, or like when you're flying the gigantic beetle through the air. Like, how do you know that you actually controlled it versus like that's just what the beetle was going to do type thing?
Well, actually, through a lot of statistics and testing, which is probably going to be the more boring side of my presentation,
okay.
But I'll get to that a little bit. I'm not sure specifically. It's about how you run the trials. So for me, what I did is I actually did. Let me just get back to this. There we go. So where I'm from, the North Jersey Regional Science Center is super particular about statistics and having, how do I put it, science that doesn't necessarily look pretty, but is heavily supported in how you tested it. So what I had to do is I had 90 trials, and it actually is 90 trials, but I'll get to it in a second. I had 90 trials, and I would have a cockroach, and it would be approached from either the left side or the right side randomly by either a false magnet or the true magnet. And I did these 90 trials on a cockroach with the device powered on, a cockroach with the device powered off, and a natural cockroach. And the purpose of this was to demonstrate that the cockroach wasn't responding to, for example, visual cues. So let's say that we have the natural cockroach and it's going around, and it's this little guy, he's going and he's climbing across this crazy landscape. He just got picked up by a human or something, and he's going like this, and then he sees this crazy arm thing reaching towards him. Maybe he's gonna naturally say, ah, that looks creepy, and turn away from it. So we could be responding to visual cues, or we could have a cockroach that's wired up to the system or has just metal on it in general, and it goes here and it feels like an animal pulling it a little bit to the side, and maybe that's going to cause it to go away. So there's other factors that could be causing the cockroach to move, whether it's actually from the visual cues or the pull of the magnet, or if it's just maybe randomly, but that's why you have to do the statistical tests and go through it. So I'm going to kind of glaze over the tests because they're kind of boring, but so initially what I did is I did a chi-square test, and this looked at the majority of my data. I think for this one I did turning correctly. I didn't actually state that there. But basically what that showed me was that the cockroaches generally had uniform movement, so they mostly continued straight instead of turning off on their own. And that also showed me that what my data is showing me, is that they're biased towards certain movements, whether that be continuing straight or turning off to a side. And then I have some more tests that I'll go over in a second. So this is my power device, and you can see that it turned correctly 40 out of the, I think it was approached by the magnet, what does it look like, 49 times? Yeah, so it was approached, again, this is randomly generated, so it turned correctly 40 out of the 49 times. However, when it was approached by the false magnet, it continued straight, I think that's 37 out of the maybe 40 times or something like that. So it's definitely biased towards those specific motions, whether it's a real magnet or a dummy magnet. And then we have the non-powered device, and again, you can see that it's generally going to continue straight. And a natural cockroach continues straight. So we can conclude that cockroaches don't have the ability to detect magnetic fields. They're not responding to their visual cues, and what I described before. So again, what I did here is I did a z-test for proportions. So this it looked at what I had for my first graph, and it compared it turning, in the presence of magnet, it compared it turning correctly when the device was powered on to the device powered off. And that showed me that the cockroach was more likely to turn away from magnetic fields when it was connected to the power device instead of the non-power device. And I did the same with continuing straight with the power device and the non-power device, and all my results were statistically significant. So does anybody have any questions so far? Yes?
So was the natural cockroach a cockroach that hadn't had the surgery done on it at all?
Yes, it did not have any metal within its body.
Okay, because I just think it's super interesting that the natural cockroach didn't respond at all to the magnet, and so maybe the cockroach with the device was learning that the magnet means that it's got to move away from it.
What do you mean learning?
Like it moved a little bit better than the natural cockroach. Like the natural cockroach, it looked like it didn't turn at all. It just continued straight no matter how many times you put the magnet close to it.
Yeah.
And the other cockroach was moving when you put the magnet close to it, even with the device powered off.
Yeah, so you're saying that perhaps with a power device it was learning to turn away?
Yeah, like at the chart, when you had like the table. Yeah, right there.
Well, what you have to remember is I did the same 90 trials on each of the cockroaches, so they were randomly generated, but it was the same 90 randomly generated cockroaches.
Yeah.
So if the cockroach with the power device was learning, well, first of all, then it would have to learn how to distinguish between the magnet and the false magnet. And again, because all the cockroaches had the same trials, the natural cockroach would have also learned in the same way. Does that answer your question, or?
Wait, so
The non-powered device, it didn't turn.
I think, are you talking about the fact that there's like
Can't
4
say
times they turned with the non-powered device?
So I was just curious, like if the natural cockroach was just so the natural cockroach was a completely different animal.
Yeah.
Okay.
Does that answer your question, or?
Sort of.
Okay. Yes.
Did you experiment with different types of signals?
Different types of signals?
Yeah.
No, I used the same frequency. which in the future I would want to experiment with probably different frequencies. The frequency that I used was, if I remember correctly, I think 55 hertz at like 2.74 volts.
Was that based off anything, or just like past experiments?
Honestly, I lucked out because that's the signal that the Hall effect sensors would put out, but it's around the same area. They actually have a broad range. They'll take frequency. I don't know specifically what range of frequency they will detect, but there is research out there that if you vary the frequency, the cockroach will respond more. So you can see again from my video, if you want me to show you that one again, that if you hold the magnet on longer, the cockroach will turn more because it's, again, that natural response is being stimulated. Cockroaches, they don't really have a brain. They don't really have free will. They're not, they actually only have a series of ganglia. Ganglia are just kind of like balls or mats of nerves going from their head down their spine. So that first time when the cockroach was stimulated, it stayed on for quite a long time. But then, as they go along, you'll see shorter bursts. And if it's running and you only do a short burst and it only has that stimulation briefly, it's going to turn less. But eventually, over time, let's say that I had the cockroach and I was stimulating it for a long time. This is a natural reflex. What's happening to the cockroach? It's triggering a natural reflex. And like any time that somebody has the reflex or their senses triggered, it's going to eventually dull. If I go and I yell really loud, then you guys are going to jump, but then the next time I yell really loud, you're going to kind of expect it.
Well, it worked. Can't argue with you now.
But supposedly, and again, this isn't something that everybody's researched before, but I've gone through most of the papers out there on it, and there have been studies that have correlated the effectiveness of the system with a varying frequency. So in the future, I would love to make like a smaller device that would be easier for the cockroaches to have. I would like to make a device that would vary up the frequency. Do you have any other questions, or?
No, that was it.
Okay. Yes.
Why do you need to do the brain surgery part versus just implanting the electrodes in the antenna?